This, okay? All right, so this particular problem, what you're going to look at is a product rule again. And when you're looking at a product rule, as you're learning it, it's kind of a good idea to write down what the product rule is. So what we're doing when we do a derivative, you're doing the first times derivative of second plus second times derivative of first. You want to get that memorized as fast as possible because you're going to use it all the time in calculus. So basically what I'm going to look at is this is going to be the first function right there, and this one's going to be the second one like this. Okay, so what we do is we just immediately go through and work out the product rule on this. You could multiply out first, then differentiate, but I want to do the product rule on this one. Okay, so here's what you do. First thing you do is you want to write down the first. You don't do anything with it, you just write it down. And I like to get students to use the notation correctly, so now you're going to take the derivative with respect to t, that's the Leibniz notation, of t to the second minus 3t plus 5. And then you say plus, and then you do it backwards. Then you write down the second. You don't touch it. Just write it down. And then you're going to multiply by the derivative of the second. Now, when you differentiate the second, it's wise to go ahead and write this way. Just write t and write t to the negative 1. Well, the reason I'm doing that is so I can apply the power rule to it like that. So again, you've got first, derivative of second, plus second times derivative of first. You just kind of do them backwards, all right? So once you got it set up, then you go ahead and do the derivative. So we're going to bring this down. Don't touch that. This derivative right here, what's the derivative of this thing? 2t minus 3, right? Everybody got that down? Okay, right? So now we're going to have t to the second minus 3t plus 5. Okay, then you're going to do the derivative of this piece right here. So the derivative of t is what? Number in front, right? That's a linear term, so that's 1. And then you're going to use the power rule on this, so you're going to have minus t, and then you're subtracting 1 from that exponent, so that'll be minus 2 like that. Okay, that's the calculus. We're done with the calculus with that, so the rest of it is algebra. So we just need to kind of multiply stuff out and clean it out. And algebra is going to be the vast majority of this problem anyway. So any question about the derivative? Okay. All right, well, let's multiply this thing out. Now, you got to be kind of careful when you're multiplying stuff out with negative exponents and stuff. So I'm going to go ahead and just kind of FOIL this one out. So if I do that, that's going to be 2t to the second. Then if I do that outside term, that's going to be minus 3t. I'm going to go ahead and write this down, but you can do this in your head. The inner term you have is plus 1 over t times 2t, and the t's are going to cross out. You can do that in your head if you're comfortable with that. And then the last term is going to be minus 1 over t times 3. I'll just write it that way, and then we'll kind of clean it up. I want to write it so you can see what I'm doing okay. All right. Now, the next one, you got to multiply all this out. This is not FOIL. It's distributive property. So you want to just make sure that you multiply the t by everything. So t squared times 1 is t. And you multiply this, so that's a negative number. That's t to the 0, right? Because you're adding the exponents. You're doing t plus negative 2. And what's t to the 0 going to become? 1. It's going to become 1, okay? Now we want to move on. And the next thing that we want to do from here is we want to take the next term and multiply it out. So we're going to take negative 3 times 1 is negative 3. And we're going to go this way. That's going to be 2 negatives, so that's a positive. That's 3t. And again, what I'm doing is I'm adding the exponents. So 1 minus 2 is going to be negative 1. Okay? And then that leaves us with taking the 5 times everything. So 5 times 1 is 5. And 5 times t, you're going to have negative 5 t to the negative 2 like that. Okay? So you got to be really careful when you do all this algebra. And it's easy. It's multiplying stuff out, but be really careful with the details. Okay? You guys see what I'm doing there? Okay. All right, now we got to clean this thing up and see what we have. So I'm just going to write everything down and just whatever I can simplify. So I'll bring that down. I'll bring this down. The t's cross out there, so that's a minus 2. Okay, this is just going to be 3 over t. So I just write that as 3 over t like that. Okay, that takes care of that. Okay, the next thing I have is t squared. T to the 0 is 1. Then we have minus 3t. I'm going to go ahead and write this thing as plus 3 over t. Okay, it's just a good idea to write everything back with positive exponents, so I'm doing that. Okay, now here I've got plus 5. And then here I'm going to write that as minus 5 over t to the second like that. Right, does that look okay? Okay, do you see anything canceling out? That's almost always what happens on problems like this. So let's see what we got that cancels. I see a 3t canceling, so that's good. No, those don't cancel. That's negative 6t. Scratch what the teacher just said. Okay, so let's see. We got 2t to the second here. I'm going to scratch that out. Now, when I put these two things together that I just marked off, that's negative 6t, like that. When I have problems like this, I kind of scratch things out. That's how I keep track of stuff. Next thing I'm going to put together is those like terms. So we have negative 2 minus 1 is negative 3. Negative 3 plus 5 looks like plus 2. So that's gone. Okay, and let's see. Where does that leave me? I forgot about that t squared. You know what I could have done, and I didn't see this, is I have 3 of those, don't I? There's a 2t squared. There's a t squared there. So that's actually 3, like that. All right, and let's see. These cancel out. So these things right here definitely cancel. So those are gone. And have I got everything? I've got, I think, minus 5 over t to the second. And that should be the right answer on that, I think. Make sure. It's so hard to make sure that you didn't make a mistake on that, but I think I got everything good there. Okay, how's that look? Does that look okay? Okay. All right. So that should be it. Okay. All right, any questions on that? Okay. All right, now what we're gonna move on and look at a few other things on here, just kind of move on with other ideas with the product rule here. First of all, that's kind of an example of what you get into in the product rule, and you can get into some kind of messy stuff there. So you got some algebra going on there. It's pretty heavy. Okay, let's move on then. Okay, you may have to look over that one a little bit. This next one's not too hard. I want to go through and remind you, if you're doing something like this and you're doing the derivative, you have two choices. I'm going to do this one way, then I'm going to do the product rule. So I'm going to start with the product rule. If you were going to do the product rule on this problem, if you square something, of course, that just means write it out twice and multiply. Okay, now we're not going to multiply, we're going to use the product rule. So I'm going to write the product rule down. You don't have to do that unless you want to. So that's your product rule right there that we're learning. Okay, so what I'm going to do is we're going to do the derivative. I'm going to write dy over dx. That means that's the value of the derivative. Okay, and the way I do this is I go like this. I write the first, and I don't touch it. Then I multiply by the derivative of 4x minus 5, like that. Okay, I'm not going to do the derivative yet. I'm just setting it up in the formula. Then I go backwards. If I go backwards, I'm doing the same thing. So I have the second, which is this, times the derivative of the first. Okay, is that solid with everybody? Okay, now let's see what we get here. We got two derivatives to do. We got to do that derivative and we got to do that derivative. Tell me what the derivative of 4x minus 5 is. 4. Okay. What is the graph of y equals 4x minus 5? It's a line, right? What's the slope of that line? 4. Remember, that's what a derivative is doing, is giving a slope of a tangent line. So you want to kind of understand those concepts and know what you're doing as you do this. Okay, so that's going to be 4. That takes care of that derivative. Then you just move over here, and that's going to be 4x minus 5. Derivative there, of course, also is 4 like that. Okay, then we just multiply it out. Right, and one way you could do this is I'm just going to do it this way. I'm just going to do distributive property and multiply it out. So 4 times 4, 16x. 4 times 5 is 20. Obviously, I get the same thing here because it's the same thing. So that's 16x minus 20. So that means the final answer should be 32x when you put those like terms together. And negative 20 minus 20 is minus 40. So that should be the value of your derivative. Okay? Now, compared to the last problem, that's pretty easy, isn't it? It should be. Okay? Now, if I were doing that problem, unless I was asked to do the product rule, I wouldn't even bother doing the product rule. Here's how I'd do it, and this is the way I would recommend you do a problem like this, is just square it out. Okay? And we've done squares of binomials in our head, and I want you to do that so you can save a little time. So what's the first term squared? What's 4x times 4x? 16x squared. What's the last term squared? Plus 25. Now remember what you do when you do a binomial, you multiply the 4x times negative 5 and get negative 20x, but then what do you have to do? You got to double it. Okay, that's the shortcut, and that's nice to know. So when you double that, you're going to get negative 40x like that. So if you do that shortcut, just make sure that you're solid when you do that. Okay, now the derivative. Tell me what the derivative of 16x squared is. 32x, right? Okay, bring that down. That's a power rule. What's the derivative of negative 40x? Negative 40. Derivative of 25 is 0. Isn't that easier that way, don't you think? A little bit? Okay, so that's the way I would recommend you do that. Although you can use the product rule on that. It works out the same way, so that's what I wanted to show you. Okay, how does that look to everybody? Does that look okay? The last problem I did, you got to be really careful about when you start seeing all those negative exponents and radicals and stuff, because arithmetic gets a little bit heavier, so you got to watch yourself on those and practice that a little bit. Okay, what we're going to look at now is we're going to develop the idea of the other main rule we learned in here, which is called the quotient rule. Okay, so first of all, what I'm going to do on here is we're going to work this problem out this way, first of all. So we're going to look at the derivative of some sort of a quotient. So the logical, simple way to do this would be just reduce that. Okay, you can subtract those exponents. That's x to the second, right? Okay, what's the derivative of x to the second? 2x. Okay, so without a doubt, that's the answer to that derivative. Okay, that's super easy. What I want to show you is this. Okay, the idea is, would it work if I just did the derivative of top and bottom separately? So let's try that and see if we get the same answer. So what I want you to write down is, let's do the derivative of the top. Let's also do the derivative of the bottom. And let's see if it works and just gives us the same answer. If it does, that would be great. So let's see. Derivative of x to the fifth, what's that? 5x to the fourth. Derivative of bottom, 3x squared. Okay, like that. All right, well, it looks like 2 of the x's will cross out. 4 minus 2 is 2. So you get 5/3 x to the second. We're out of luck. It doesn't work. Okay, so the thing is, mathematicians had to figure out a way to do quotients. Okay, because they get really complicated, so we kind of proved and developed what we call the quotient rule. So the thing that's important on that is understand that if you have a quotient, you can't just do top and bottom separately. It does not work. Okay, so you want to get that in mind. When you have a quotient, you have to apply the quotient rule. So here is the quotient rule. I am going to go through and kind of give you a little proof of that, too, just because I like to begin to show proofs at this level of a class. So it looks pretty intimidating at first glance. You'll have to memorize this too, because you're going to use it all the time in calculus. So if you're doing a derivative of 2 functions, f of x over g of x, here's how it goes. You take the bottom function and you multiply it by the derivative that's in the numerator. Then you subtract. Then you do it backwards. You do the function in top. Then you multiply it by the derivative of the g of x. And then it's all over the square of g of x. Okay, don't learn it that way. Learn it in words. Okay, that's how I learn all this stuff, is in words. Right, this is the way I do it. Okay, it's just the bottom times derivative of top minus top times derivative bottom over the square of the bottom, over bottom squared. So it's bottom times derivative of top minus top times derivative of bottom over bottom squared. Okay, that's one way. Okay, and you believe me, you'll get it because you'll do it so much. Okay, so that's one way to remember that, is like that. Okay, so on the next page, here's another way. Some students like this. I never learned this, but I've seen some teachers use this, and this is kind of slick. So this just says, if you have like u over v, you can think of the u as high and the v as low. So you can think of it as low d high minus high d low over the square of what's below. How cool is that? That's like a little jingle there. I was like a little rap there. So, and the D means derivative of. So a lot of times students just say low-D high less high-D low over low-D lower or something like that, okay? So I always just do bottom times derivative of top minus top times derivative of bottom over bottom squared. But you can do that way too. Sometimes students catch on to that better, okay? All right, so what I want to kind of talk you through here a little bit is I just want to kind of go through the details of the proof of the quotient rule. I just wrote it out for you because my goal here is for you to start seeing how this difference quotient is used to develop derivative formulas, okay? So if you go through and do this, we are looking at the derivative of this, and I'm going to the difference quotient, okay? And remember what we're doing is this whole thing right here could be thought of as just, you know, the f of x thing. This whole thing right here could be thought of as f of x plus h. Okay, that's just like the formula we learned for a derivative, except what I'm doing is I'm doing an entire function that's a ratio. So that's how that thing sets up, is like that. Okay, now what I do in this, and I didn't show all the steps on this and everything, the idea is you have a complex fraction, so I'm not just, you don't need to write this down, I just want to see if you follow this okay. So what I'm doing is I'm going to get rid of the g of x plus h, so I'm going to multiply the top by g of x plus h, and I'm also going to get rid of the g of x, and I got to do that whole thing to the top, and then I got to do that, of course, to the bottom, so I'm going to have g of x plus h times g of x like that. Okay, well, here's what happens, okay? So, and if you look at something like in a math book, when you get in higher math, the math books are notorious for leaving out steps, okay? I mean, it's assumed that as a student you can fill in the gaps, okay? Sometimes that's hard to do, but that's kind of the way these things are written. So what's going to happen on this is that's going to cancel that out, and that's going to leave you f of x plus h right there, and then when you multiply the g through there, that leaves you with that. Then on this side, the g of x is going to cross out, and that's going to leave you f of x times g of x like that, okay? Now that's something that you guys want to know how to do in your head when you're doing complex fractions. I just kind of teach it like this, is you're really multiplying those things out, and you can see on that, I think that cancels, so you're left with that. When you go over here, that cancels, so you're left with that. So you guys see that okay? Okay. We've done complex fractions, so that kind of takes care of that then. And then what we do is, well, a mathematician, when they're proving stuff, a lot of times they have to use little tricks. So what they're doing on this is I'm bringing this piece down right here, and then I'm also bringing this piece down right here, and then this thing right here we just added in there. We tacked that in there, okay? And I didn't change the problem because those things cancel out, don't they? One's negative and one's positive. So what happened is by doing that, then we can kind of group this together. So the way this works is like this. This thing right here, this whole thing right here, is going to come down to here. But what we've done is we've factored a g of x out of that. So just in your mind, that g of x came out of there, and you're left with f of x plus h minus f of x, like that. Okay, and then this thing right here, this whole thing is going to be grouped together in another limit, so it comes down, and the f of x is a common factor. So then you'd be left with g of x plus h minus g of x. Now what I did on this is kind of a slick trick, okay? Notice on this that minus right there turned into a plus. Now think about why that happened. Notice what I did on here is, what I ended up doing is I ended up flipping these things around a little bit here. So what I did is I just sort of factored that out like that. So when I come down to the next step, because this thing gets turned around, see how that gets turned around? Right? That's why that plus becomes a minus. That's just a simple thing like that. Now, if you look at this, now this is what I want you to see. That right there, isn't that a derivative right there of f of x? Okay, that's f of x plus h minus f of x. That's the bottom function. So what you have is the bottom times the derivative of the top, and then you have the top, f of x, and isn't that thing right there like the derivative of g of x? Okay, and then you end up having g of x plus h, but when you let h be 0, that goes to g of x squared. It's just g of x times g of x. So once you let the h be 0, there's your quotient rule right there. Did you follow that at all? I don't know. I'm always curious. Okay? Because that's kind of what you get into as you study math at a higher level. You start looking at proofs and where things come from. Okay? And that's the idea of where the quotient rule comes from. Okay? All right. So let's work a little bit with a quotient rule on this one. I want to show you how the quotient rule works on this example we just did. So again, if you did this problem the easy way, well, obviously you would just do that. You would just change that to x squared, simplify that out, and then we would know the derivative would be what? 2x, right? Power rule, 2x, okay? Now let's go ahead and do this with the quotient rule. All right, now the quotient rule, the way that you'll see me write this is don't write it like this. Just learn it in words. It's just bottom times derivative of top minus top times derivative of bottom over bottom squared. That's the best way to learn it to me. Or you can do that high-y low, low-y low, whatever you want to. Okay, so this goes like this. The bottom is going to be x to the third. Then you're going to do the derivative of the top, which is x to the fifth. Then we just do it backwards. Then we do the top, which is x to the fifth. And then we do the derivative of the bottom, which is x to the third. And then we take whatever's in the bottom and we square it. Okay, so that's how that thing gets put together. So again, if you kind of look at that, I'm just doing the bottom goes there. Okay, and then I got the derivative of the top, and I got the top derivative of bottom over bottom squared. Okay, does that look okay? Yeah.
The derivative of the bottom on the right side?
What's that?
Is the derivative of the bottom 3x to the second?
We don't do anything with the in the denominator right here. You just square that. So we're going to go ahead and do the derivative of x to the fifth and the derivative of x to the third.
Oh, okay.
So what we're doing is just taking the bottom, differentiating top, doing it backwards, then it's bottom squared. Okay, like that. All right, well, let's finish it up and let's see if we get the same answer or not. Okay, so this is x to the third. Tell me what the derivative of x to the fifth is. 5x to the fourth. Okay, everybody should have that down by now, hopefully. What's the derivative of x to the third? 3x squared. What's the square of the bottom? Good. I always ask that to see if anybody says x to the fifth. Okay, you multiply exponents in that case, right? Okay, so you do that. Now what you're going to have is when you multiply this out, that's going to give 5x to the seventh. This is going to give 3x to the seventh. And then that's going to give x to the sixth, like that. Okay? Well, the like terms are in the numerator. So what you have is 5 minus 3 is 2x to the seventh over x to the sixth. Are you going to get a 2x out of that?
Yes.
Yep, definitely. Because, well, all you're doing is just subtracting those exponents. 7 minus 6 is 1. So, yeah, you get 2x. Now, obviously, you would rather do that problem the way on the left. But what I'm showing you is how the quotient rule works. And it always works. As long as your two functions are differentiable, then it's always going to give you a derivative. Okay, that's what we proved, is that's a formula for a derivative of that sort. Okay, any questions about what I did there? Okay, now I'll tell you the quotient rule gets heavy with algebra, so you got to get ready for that because it will happen. So you're going to get a lot better with your algebra in this class because that's mostly what you're going to be doing here. Okay, so going to this next thing, we're going to go ahead and set this one up with a quotient rule. You pretty well are forced to do this one with a quotient rule. You can't really simplify. You could factor the numerator. That's the sum of two cubes. I'm not going to really worry about doing it that way. I'm just going to go ahead and do the quotient rule. And just for reference, I'm going to write down what it is. You can write it down if you want to, but you don't have to. So it's bottom times derivative of top minus top times derivative of bottom over bottom squared. Okay? And what you want to do is you want to start by making sure you can put this in the formula correctly and getting that done. Okay, so we start by just writing the bottom, which is x plus 3. And then I prefer that you set it up in the formula before you do the derivative until you get a little more experience with it. So we do the derivative of the top, like that. And then you just do it backwards. We do minus, follow the formula. Then we do the top. Okay, then we're going to multiply by the derivative of the bottom, like that. So that's how you get that set up. And then when you do the bottom squared, you just write this like that. Okay? Does that look okay for everybody for the setup? Okay. Now you can go ahead and keep going with it. I'm going to go ahead and just do the derivative. We are going to have some simplification we do in here. So the next thing you got to focus on is you need to do those two derivatives. And you want to write a lot of steps on this. Write things just very methodically. Take a lot of room on your paper when you're doing this so you don't get lost. So that's x plus 3. What's the derivative of x to the third plus 27? 3x squared. Okay, that's good. Then you got the minus x to the third plus 27. Okay, what's the derivative of x plus 3?
That's 3x squared.
1. Right? The derivative of x plus 3 is 1, right? I always ask that because students, a lot of times, that's the easiest one, but they don't get it.
So x in the first power, the derivative.
Well, here's the thing. X plus 3 is a line, right? Isn't that a linear equation? What's the slope of that line? See, one thing you want to drill yourself on, because it's going to show up over and over again, if you had the derivative of 3x, what's that? 3. If you had the derivative of 1/2 x, what's that? 1/2. Okay, all right? You got to see that when it shows up. You don't have to use a power rule on that. You just see that that's 1, okay? All right, now the bottom squared. Now, one thing when you're doing this, there's not really any time I can think of when you need to take the time to multiply that out. Leave the bottom squared as it is, because your goal usually is to see if you can maybe get that to cancel, although most of the time it doesn't. But you want to have things in a factored form, really, okay? So now what we do is we just multiply this out. So I'm going to go ahead and multiply this out. That's going to be 3x to the third. That's going to be plus 9x to the second. Okay, now be careful with this minus. Make sure that you do this minus the right way. I see students mess up on that a lot. That's minus x to the third minus 27. Of course, if I'm multiplying something by 1, it doesn't change it, but that negative distributes through the parentheses like that. Okay, so far okay? Okay, now it looks like all we can do on this one is just maybe put some like terms together in the numerator. So it looks like 3 minus 1 is going to be 2x to the third. Then we have plus 9x to the second. And then I've got minus 27. And I've got this. Now, the only thing that you would do on this problem ever at the end of this is just see if the numerator factors and cancels out anything in the bottom. And it doesn't. You really wouldn't be able to factor anything in the numerator. So one of the things that's going to come into play in these problems pretty heavily is factoring skill. Okay, and the factoring skill is a little higher level than you would have saw like in pre-calc or college algebra. It's just the way it is. Okay, so do you guys follow everything I did there okay? To me, that one's not too bad. That one's got pretty basic algebra in it. Is there any question going on with anybody there? Okay, all right. Next one's harder because it's got radicals in it. So that's another thing you want to make sure that you know how to handle good is the situation with radicals. Okay? Now, this one again is a good quotient rule. So, again, what we're going to do is set this up. Now, I do want to see if you guys notice. I have a serious typo on this problem. Do you see what's wrong? Now, the variable's got to match, okay? So, let's go ahead and let's rewrite this. Let's use t just for something different. You know, in physics, you use ddt because you're dealing with time a lot. So, let's just change this to square root of t plus 4. And I also have a typo there. That was not intended, I don't think, for that whole thing to be in a radical. I mean, you could do it that way, but I think my intention on this was probably to do this like this. Yeah, that's what I intended. I just typed that in there wrong. So you want to get that changed to that like that. Now, you could do it with the whole radical all over the top bottom, too. It doesn't make any difference. That was just the intention, okay? All right, so what we're going to do on this one, first thing you want to do is you want to get this set up in your quotient rule. So when you do that, you're going to write the bottom down, whatever it is. So that's square root of t minus square root of 2. Okay, then you want to go ahead and set up that you're going to do the derivative of the top. Now, what do you need to do when you do a derivative of a square root? What did we learn? Write it as a what power? 1/2 power. Okay, so you might as well go ahead and do that now, see. So we go ahead and write that as t to the 1/2 plus 4, like that. Then you want to do it backwards. We're doing minus. And you can leave that. I'd probably go ahead and change that also to t to the 1/2 plus 4. You could even do that on the first one too if you wanted to. I'm just going to leave that alone for now. Then we're going to do the derivative of the bottom. So I'm going to write that again as t to the 1/2. Now the square root of 2, the reason I'm not going to take that to 2 to the 1/2 is what is the derivative of the square root of 2 anyway? It's 0. It's a constant, right? Okay, so you don't need to bother doing that unless you want to. It wouldn't matter, though. Okay, then we got the whole thing. It's a big, big fraction. That's the entire numerator. Then you have the bottom squared. So I'm going to write that as square root of t minus square root of t squared, like that. So really the key thing is when you differentiate these two things, you need to write that squared on 1/2 power. And it's helpful to do that sometimes when you're simplifying as well. All right, so that's the setup, okay? That's the first thing I'm going to make sure everybody's solid with is that's the setup of the quotient rule, okay? What you need to do from here is you need to bring stuff down, and then we're just going to do the derivatives, and then we'll see what kind of algebra we're going to get into. So this is square root of t, square root of 2. I'm just going to leave that alone. Okay, what's the derivative of t to the 1/2? There you go. Now, see, you want to start doing that in your head. So you're doing bringing down the 1/2 and you're subtracting 1. So I'm using a common denominator, right? So that's going to be 1/2 t to the negative 1/2. Okay? The derivative of 4 is 0, right? So you don't need to put anything there. Okay? So that's what that derivative is. Then we have minus t to the 1/2 plus 4. We don't do anything with that. Now we do with the derivative of this. The derivative of this is the same, isn't it? So if you're doing the derivative of t to the 1/2, that's 1/2 t to the negative 1/2, and then the derivative of that constant is 0, so that's going to be the same. That's going to be 1/2 t to the negative 1/2 like that. Then it's all over the bottom squared. Okay, like that. Okay, calculus is done. Okay, we do have to simplify, and you got to simplify these things all the way to the end. Okay? Does that look good? Okay. All right. Okay, let's proceed. Let's see what we got here. Now, what I'm going to do on this is this. Now, watch this carefully, because when you're doing a quotient rule, you have to learn how to factor. Okay? One thing that you got two choices. You could distribute that. You could distribute that. You could do that if you wanted to. But I want you to notice, isn't that the same? That's a common factor. It can come out. So when you have a common factor, it's advantageous to do that. And you'll see me doing that on the quotient rule all the time because it's easier. Now, sometimes factoring seems a little harder than what students are accustomed to in this class. So what I'm going to do is I'm going to go ahead and that's my common factor. I'm going to take it out. So I'm going to write that as 1/2 t to the negative 1/2. Then I'm going to draw a big bracket. Okay, and what's left after I take it out is this and this. That's what's left over, see. So this part is your common factor. That comes out. Then you're going to be left with, and you need to write this like square root of t minus square root of 2 minus, and you got to have that parenthesis because you're dealing with that negative. That comes out like that. Then you have the bottom squared. I'm not going to do anything with the bottom. I'm just going to leave it in a factored form for now. Okay, so I have that then. Okay, does that make sense? So I did that? Okay. So if you see a common factor, take it out. It's easier to do the problem that way, see? Okay? And you'll make less mistakes, so you want to take that algebraic approach. So now what I'm going to do is I'm just going to bring this down. I'm going to leave that alone for now. And then when I look inside the parentheses, one thing you're going to notice on this, I'm just going to write this as square root of t minus square root of 2 minus, I'm going to take that back to a square root, and then minus 4. I'm going to distribute the negatives through like that. then I'll have square root of t minus square root of 2 squared like that. Okay? And then I'm getting pretty close to being done with the problem. All right, what do you see inside the brackets? Okay, something cancels. Okay, a lot of times that happens. That's certainly nice when it does. So let's bring it up here and let's see what we need to do here. So it looks like all I'm really left with on this one is I've got a 1/2, and I'm going to go ahead and take that and I'm going to bring that down and write that as 1 over 2t to the 1/2. And then I'm left with, I'm going to write that as just negative square root of 2 minus 4. You can't really do anything with that. And then I'm going to leave this alone like this. And then the only thing I'd probably suggest even doing on this one is you've got a complex fraction, so I would just get rid of it. So the idea from here is you would like this to go away. Okay, you have a fraction within a fraction. So tell me what you could do to make that 2t to the 1/2 go away. You multiply by it, exactly, but you got to do the same thing in the top and bottom. Okay, so what you could do is you could take the top by 2, and let's just change that to a radical. I want my answer to be in a radical form. And then, of course, you would have to do the same thing to the bottom. Okay, like that. And when you do that, see, that would cancel that out. And then you would have this, and I'll just take this as the answer. This is fine. So I'd have negative root 2 minus 4 over, and I'm going to write that as 2 root t square root of t minus square root of 2t squared like that. Weird answer, but that's what it is. Okay, that to me is the simplest way to write that. Uh-oh, sorry. What's crazy, I wear hearing aids, and when I get a phone call, it goes in my ears, and I start hearing this ringing and stuff. Sorry about that. Okay, so is there anything that you want me to go over on that again? Because that algebra is messy on some of these things. That's what you got to get into.
Could you explain where you got, I understand why you would put the 1 over 2t half to the power of over 1 over half. I understand why you would put that, do that so you can get rid of the negative, but where do you get the extra 2 from?
Which extra t are you talking about? Are you talking about where up
the
here?
2 that's underneath, that's right next to the variable.
Well, what I did from here to here is I moved that down, like you said.
Right.
And the reason I did that is because I want to get rid of it. See, even right here, I have a number I can get rid of. I could have just got rid of the 2, and I could have just left it that way if I wanted to. Okay. What I decided to do is I wanted everything in radical form, so I went ahead and did that, and then I multiplied to get rid of that, so that I have a cleaner looking fraction. So I don't want complex fractions in my answer typically. So that's what I did is I want that to go away. So I multiply by that, top and bottom, that makes that go away, and then you don't have a complex fraction anymore. That's the idea. Okay? Thank you. Quotient Rule has a lot of algebra that you're going to learn from. You'll get way better with your algebra, like I've said. Okay.
If you expanded the denominator, couldn't you get rid of some square roots? Or
you could. I'm kind of making a decision not to do that. I mean, you might be thinking of maybe conjugate or rationalizing denominator. You don't need to.
When you're done.
You don't need to. That's a great question. You don't know. There's a lot of ways that you can. I could have wrote the answer to this in a lot of different ways. Okay. Generally, I guess when you're doing your homework, they try to guide you where to go, and they usually try to take multiple answers. This problem was kind of a weird problem, but you could write that in lots of different ways. Yeah, you could get rid of radicals. In general, for things we're going to learn later, you want things in a factored form. Right. You do. I mean, you want everything factored because then you can find things that we're going to learn called critical points and stuff like that. Okay? Okay. All right, let's go this one. This one's probably not as bad, so let's go ahead and see what we can do on this one. Now, what I want to do with this one is I want to get it set up. Then I want to give you guys a few minutes to see if you can finish it. Let's go ahead and set this one up and see what happens. This one probably is not too bad. Now, one thing I would look for on a problem like this, I would first of all think to myself, can I factor and cancel? So a lot of times what happens if you have an expression, Sometimes it's good to simplify, then take the derivative. This one, I don't think there's any simplifying you can do. I don't see any factoring that's going to work on that. So let's go ahead and just put this in the quotient rule. And we got dy dt is the notation we'd use. So again, what we do is we just write down the bottom. Don't do anything to the bottom, just leave it alone. Okay, then we're going to multiply by the derivative of the top. Okay, and then we do it backwards. Okay, you got to have this in the right order too. So now we do the top. And then we're going to multiply by the derivative of the bottom. And then the whole entire thing, you're going to have the bottom squared like that. Okay, now I'm going to do one more step and I'm going to let you try to finish this one then. Okay, so let's do the derivatives of those, which are pretty simple derivatives, and I'll just give you a little algebra practice here, and I'm going to walk around and see what my students know about algebra because I need to find out. Okay, what's this derivative right here? 6t plus 2, good, okay, minus 3t squared plus 2t minus 1. What's the derivative of the next one?
Negative 2t plus 4.
There you go, okay. Then you got the bottom square. Now, what I'm going to suggest that you do on this problem is once you got everything set up, and you can go ahead and I'll let you try to finish it here. I don't really see common factors there or anything. So what you need to do is just multiply that out. Multiply it out. Multiply that out and collect all the like terms. Okay? Let's see if you can do that. Okay. I'll give you a couple minutes to work on that then. Okay? You finish, and then you'll be able to look up here and see if you got it okay. I just want to make sure you can handle the sign issue on this okay. All right, I think I got it. And I'm just kind of curious how many people got down here. I'll give you a little time to look over that and see what you got. The thing that that students a lot of times don't do well when they're doing the quotient rule, all the algebras keep track of all the maths. Okay, so I mean, but if you get down to that answer, then you'd have to double check, make sure all your multiplication's okay. And you got to write steps. That's another thing students just don't do well with is write steps, keep repeating stuff. So I did all the multiplication and collected the like terms. And at the very end, that's when I changed the sign. So that's why I have the plus, minus, minus, plus there. Okay? Did anybody get it right? Okay, you did? Okay, that's pretty good. That's not too bad. I just want to kind of make sure that you see what you're going to get into with the algebra here. Now, there are some choices on here. I mean, you could factor a 2 out of that. You don't have to, but that does have a common factor of 2. This does not factor, so I just leave the answer like that, okay? So you just got to deal with it. The algebra is just going to be a big deal in this class, and you'll get better at it. If you're going to go to Calc 2, you certainly need it, because we were doing problems the other day that took like about 20 steps on our paper and took like 2 pieces of paper to do, so it's just you got to keep track of all the mess, okay? So try to learn to write things out just like I'm doing there, very methodically, and keep bringing stuff down and just pay attention to your arithmetic, okay? Okay, let's see. Is there any question about that? I'll leave that up there just for a few seconds more here, and then I'm going to look a little bit at going back and kind of doing a tangent line. I'm going to repeat that kind of as I teach these things. Okay, any questions? Okay, all right. And I'll post these things online too, or you can always just take your phone and take a picture if you need to get something down real quick. I'm fine with that too, okay? All right, let's go ahead and let's move to this one. And we're going to do an equation of a tangent line. So when you're doing an equation of a tangent line, we've done that enough by now that the idea is when you do an equation of a tangent line, the formula you're ultimately going to use is y minus y1 is equal to m times x minus x1. Okay, so ultimately we need to work with that a little bit here. Okay, well here's the thing in this problem. Well, I've given you x1 and I've given you y1. So x1 is going to go there, and we know y1 is going to go there. Well, what are you going to do to find m? Now do the derivative, right? You do the derivative, and then you figure out what that is. Okay, well, we got to do a quotient rule on this problem. So the big part of this problem is going to be doing the derivative of this function with a quotient rule. So we need to go ahead and get that started and put that together now. Okay, so what I'm going to do is I'm going to write f prime of x. Usually if I have f of x, if I have that function notation, I usually go f prime. If I had y, then I'd do dy dx. I use the Leibniz notation. Okay, so we're going to do bottom, and then we're going to multiply by the derivative of the top, and then minus the top, times the derivative of the bottom, and then all over the bottom squared like that. Now, one thing that I don't mind you, like in your homework, once you practice this and you start doing this over and over again, you're okay, like on your homework, if you wanted to just go ahead and do that in your head, because that's going to be 2x, right? And then this right here is going to be what? 1. So you can go ahead and do that in your head if you want to. When I'm teaching this, I kind of like to get everything set up and get you solid with how to set that up using the notation correctly. Okay, but on your homework, you can do that derivative in your head if it's pretty simple. So this would be x minus 1. Okay, when I do this derivative, that's going to come down to give just a 2x. And we got minus x squared plus 3. And then this derivative right here is going to be 1. And then I'm going to have all over x minus 1 to the second like that. So that's not too bad. Okay, usually it's when you got negative exponents and radicals, that's where it gets a little challenging for students. Okay, now I'm just going to carefully multiply this out. So I've got 2x to the second minus 2x. Okay, this is the minus has to distribute, so always be careful with that. That's minus x squared minus 3. And that's all over x minus 1 to the second like that. So that's how that's going to go together. Okay, and let's see what we have. It looks like if you simplify the numerator, you're going to have 2 minus 1 or x squared minus 2x minus 3, and then all over x minus 1 squared like that. Okay, so that's the simplification. Now, you got two choices here. Now, when you find m, okay, you got to find the slope of the tangent line when x is negative 1. So you could go ahead and now just plug in negative 1. I'm not going to do that. I see something. Do you guys see anything on that expression? Yeah, the numerator factors, okay? And I think it might even cancel it. Did you already try it? Okay.
It's x plus 1.
Okay. I thought that by looking it might. Okay. Let me just make sure. Okay, let's go ahead and try to factor it. I think it's a good idea to just try that. I was thinking that it might factor, but it does factor, but it doesn't cancel. So you've got 3 and 1.
Yeah, but you can't put a negative 1. Why not? Because that doesn't make it.
Yeah, okay. Yeah, that's right. It factors like that, so it doesn't cancel. But you know what? To me, it's easier to plug in the negative 1 in that form anyway. So to me, you want to be on top of if something factors, try it out and see if anything cancels. Okay, so you got that. Okay, now what we're going to do is we're going to do f prime of negative 1. The reason we're doing f prime of negative 1 is because I'm interested in finding the equation of the tangent line at x equals negative 1. That's part of the problem I gave you. Okay, so now what you do is you just plug stuff in. So let's do the factored form. Okay, everywhere you see an x, you want to put in a negative 1. So we'd have negative 1 minus 3 times negative 1 plus 1. Oh, I love this, the way this is working out. Then that's minus 1 squared, like that. Okay, so that's going to end up being negative 4 times 0 over negative 2 squared. That's 0 over 4, so it's 0. I like it when that happens. That was awesome. That makes the problem way easy. Okay, all right, so see what I'm doing is I get the derivative, then I plug it in, and see if the thing that you could do on this too is, I mean, you could plug it in here if you wanted to. If you didn't see the factor, you can plug it in there. You'll still get the same answer. Okay. So what we're going to do now is we're now ready to finish up this problem. So I go to my formula right here, and when I got this put together, I have y minus negative 2. That's the y value I gave you. The slope is 0, so that goes there. Then we have x minus negative 1 like that. Okay, get that put together. That looks like that's going to be y plus 2 equals 0. So we get y equals negative 2. So that should be the equation of your tangent line. What we're going to do is going to look at this graphically and just kind of check what this thing looks like graphically then. Okay. Okay, do you guys follow the stuff I did on that okay? Okay, now we've done those tangent lines quite a bit. That's just kind of a basic thing you do in calculus. So let's do, if you want to get your calculator out, let's go through and let's kind of see what this thing looks like on the calculator, just kind of visually. Let's see what we got. Now, one thing I want to make sure that you guys are aware of, when you put this in your calculator, you need to make sure that you have parentheses around the top and bottom. The students a lot of times do not pay attention to that. So I'm going to put in x squared plus 3, close the parentheses. This is the way you always want to do a rational expression in your calculator, is have the stuff in parentheses. Then we'll have x minus 1. So just kind of put that in like that. Now we're going to go ahead and just do a kind of a simple graph on that. So I'm going to do a standard window once I get that put in. So you want to get that put in like that, using parentheses, and then just go zoom 6. And that'll be the graph of the function. Okay, that's some sort of a rational function. Okay, now, why is this thing breaking at x equals 1? It's undefined, right? Okay, yeah, if you look at this function, you're discontinuous at x equals 1 because you have a vertical asymptote. Okay, well, So let's just all I'm going to have you do is just kind of take a few points. We're going to make a very cheap sketch of this, okay? And I just mean get a few points so you can trace like at a couple of places. Like if you trace at 0, you get -3. So that's a nice point. If you were to trace at -1, I think that was the point we already had anyway. That's the point -1, -2. So we have that, and then from there, just wing it. I'm okay with that. Okay, that's not a very good wing. It goes more down like that. Okay, and then the other part right here, just kind of wing it. Okay, I mean, you got your technology's kind of showing you what you have. Now, there's another thing going on this. I want to see if you guys see this or not, because we've talked about this before. The degree of the top is bigger than the degree of the bottom. What does that tell us?
There's a slope there.
Yes, it has like a slant asymptote. Can you kind of see that? There's an asymptote that's kind of, see how that's slanting? That thing is going to infinity and it's going to -infinity. If you did long division on that, you would get basically the equation of that slant asymptote. So I just wanted to mention that. So basically now what we want to do is, well, just graph your tangent line. You don't need to do that on the calculator. I mean, if you do the graph of y equals -2, all that's going to do is it's going to be a horizontal line anyway. And then that'll give you your curve. And then your tangent line's going to be going through that. It's going to be touching that point like that. So that would be, visually, you can tell that's right. Okay? And what happens on this, and we'll get into this during the semester, is this thing right here we call a local maximum. And what happens is the slope of the tangent line is 0 right there, isn't it? Okay? And that's what we're going to end up doing is, if you figure out where the derivative is 0, that helps you locate minimums and maximums like that. Okay, how's that look to everybody? The only thing's different is the derivative is more work now because of the quotient rule, but it's the same principle, okay? All right. So let's go through and let's do a couple of more things before we do a break here. So I want to work a little bit on the derivative of e to the kx, okay? Now, our textbook shows this early in the semester, to me almost in a place where it shouldn't be, but I'm going to go ahead and teach you what this is, because what we'll be doing next week is we'll learn what's called the chain rule, and once you learn the chain rule, you'll understand this better. So there's two things that we've talked about this already. If you have the derivative of e to the x, we did this last time, what did we say that was? E to the x. Okay, that's the easiest derivative rule there is. Derivative of e to the x is itself. That's what makes that a magic function. Okay, but if you have something like e to the kx, well, the derivative ends up being k e to the kx. Okay, and the reason for that, I'm going to show you something on this as I'm doing these problems that'll kind of help you understand the chain rule when we get to it. So what this is saying is, like for instance, if you had the derivative of something like e to the 10x, okay, well, it turns out that it's just itself, but since there's a 10 there, it goes there. Okay, you want to learn how to do this real fast because it shows up all the time in calculus, so you want to kind of drill yourself on how to do that. So if you had e to the -2x, the derivative is itself, and then really it turns out that it's just the derivative of the exponent. What's the derivative of -2x? -2. So that's what you do, is you just have itself, and then that k goes in front of the e like that. Okay? So we're going to do a couple of derivatives on these. These are actually very easy to do. And when we go down to this problem, when I do f prime of x, the way you would do this is like this. This is a constant, okay? That 9 is a constant, so remember when we've been doing derivatives, we write the constant down, okay? Then we're going to multiply by the derivative of e to the 3x, okay? You're not doing a power rule on this. Sometimes I see students bring that exponent down. That's not how you do it, e to the x. That's a totally different idea. So what you'd have is 9. Now, tell me what the derivative of e to the 3x is, just in your head. 3 e to the 3x, right? Okay, so what you have is the 3 comes down, and then you have e to the 3x, So the answer to that derivative, you just multiply and get 27 e to the 3x like that. Okay? That's how it goes. Okay? That's very easy to do. Okay? And that's going to show up in calculus all the time when we're dealing with exponentials. Okay? All right? The next one, now I'm going to have you rewrite this as 2e, and when you have t over 2, it's probably beneficial to write the problem that way and realize that t over 2 is the same thing as 1/2 t, right? Okay, if you have a t over 2, that's 1/2 t. There's a 1 in front of that t. Okay, so the way that you would do this when you're doing the derivative is, again, you would write down the 2, that's a constant, and you don't have to write all these steps down. I'm just showing you what the exact thought process is. So you're writing the 2 down, then you're doing the derivative. Okay? All right, so let's see what we have then. Okay, tell me what the derivative of e to the 1/2 t is. 1/2 e to the 1/2 t. See, it's itself, and then it's just that number in front of the t. So that's going to end up being 1/2 e to the 1/2 t. That's what that formula tells you. Okay? Now, what do you see happening? 2's cross out, so you're left with e to the 1/2 t like that. Now, you could write it that way, or you could take it and write it as e to the t over 2. They're the same thing. 1/2 t and t over 2 are the same thing, right?
Did you turn that into a rational expression or a radical expression?
No. Okay, you're thinking of this, right? Okay, yeah, okay. So no, you just leave it alone. This is not a radical, it's just like linear, like mx, like 1/2 times something, okay, like linear. Okay, you guys follow that okay? All right. Okay, let's do one other one here, and now we'll go ahead and do our break. So with this one, let's see if we can figure out how to do this one. Now this one you have a quotient, right? You have two functions. You have something in the numerator, something in the denominator. What are you going to do? Quotient rule. You have to. Okay? So what we're going to do on this one is quotient rule. And we got to get everything set up. Now we do have that e to the 5x in there, so we have to deal with that when that comes out here. Okay, so what we're going to have is we just write down the bottom, e to the 5x, then we're going to multiply by the derivative of the top. Then we do it backwards. We do minus the top, and then we do the derivative of the bottom. Okay, then we go all over the bottom squared like that. You can use brackets or parentheses, it doesn't matter. I just use them brackets for some reason. Okay, all right, so what we need to do is do our derivatives and just kind of look at, you missed, whatever things that we have here. Okay, try out for the nuggets. Okay, all right, so from here, we're going to have e to the 5x. And then what's the derivative of 2x? 2, okay. All right, and then we have the 2x. All right, what's the derivative of e to the 5x? 5e to the 5x, good. Okay, 5e to the 5x. That's the rule that we just learned. So we write that as times 5 e to the 5x. Now, oh, I see students do this wrong all the time. Tell me what the bottom is. E to the what? Is it e to the 5x squared or is it e to the 10x? 10x, okay. What do? You multiply exponents. A lot of times students, they see things that they haven't encountered before. You know that x to the second, x to the third is x to the 6th, right? But you multiply exponents. So that's going to end up being e to the 10x like that. Okay, so algebra rules that you got to know. Okay, now what I'm going to do is I'm going to clean this up a little bit. I'm just going to write that as 2 e to the 5x minus, and then 2 times 5 is 10, and then that's x e to the 5x over e to the 10x like that. Okay, now you want to look at this now, because what I said, when you're doing a quotient rule, factoring is a big deal. Look at the numerator. Do you see anything that happens in the numerator? Factoring ones.
We can pull out the
That's common, right? Then you got a 2 and 10, which has a common factor of 2, right? Okay. Yeah, you just take that out, okay, and then simplify that. And what will happen is I think we'll have some cancellation in that denominator when we do this problem then. So let's go ahead and do that, because every time you do the quotient rule, you need to think about factoring. So what I'm going to do is take this out. We also have the factor between 2 and 10 is 2. So we're going to take our common factor out of 2e to the 5x, like that, okay? Now just kind of think in your mind what you're going to have here. What do you multiply 2e to the 5x by to get itself? A 1, okay? All right, do this in your head. What do you multiply 2 by to get 10? 5, and you also need an x, right? Okay, you got to have an x. Every time you factor something, check it in your head and make sure it's right. Okay, that's 10x e to the 5x. Now what I have here is still have the e to the 10x. Okay, does that factoring look okay? That's the algebra issue that we deal with a lot here in this level of a class. Now, is there anything else?
But do we have to take the 2?
You don't have to. I just go ahead and whatever I have, take it out. You wouldn't have to, though. You could get by without that. What do you notice there? Yeah, those reduce. Now, what you're doing is you can look at it this way. You subtract the exponents. So, like if you had x to the 5th over x to the 10th, that's x to the negative 5, right? But really, that's 1 over x to the 5th. So what you can do is just in your head, what's happening is you are really getting e to the negative 5x, right? When you subtract that 5x minus 10x, you get that, right? So what you end up with after you cancel this is you end up with an e to the 5x in the bottom. Just think of it this way. There's 5 e's in the top. There's 10 e's in the bottom. Isn't there 5 more in the bottom? Okay, that's the way I look at it. Okay, that cancels. Okay, then after that, you're left with 2 times 1 minus 5x. Okay, so this right here would be a good answer. And yet you could have left that 2 in, like you were talking about, Alicia. So, or you could go ahead and multiply it out and get like 2 minus 10x. Okay, like that. Okay, these are the little algebra issues that, we have to deal with a lot in this level class. Does that make sense to everybody? The same principle as this. When you do something like this, a lot of times students have never learned this the best way. The best way to learn this is, which part of the fraction has more x's? The bottom. How many more? 5. You see what I mean? You do it in your head. Same thing there. 5 there, 10 there, there's 5 left over. Does that make sense to everybody? Okay, you're going to deal with that kind of stuff in here all the time. Okay, so, all right, so let's go ahead and, okay, you never want to make things more complicated than they need to be, right?
Wait, what?
Yeah? Okay. Okay, what a lot of students would do on a problem like this is, let's start going for the quotient rule. Do you see anything in that problem? How about that bottom?
We can factor out.
Yeah, you can factor a 3 out and see if something happens, okay? The point of this problem mostly is, before you go jumping into the quotient rule, always see if you can simplify something. Okay, so that's what I'm going to do on that, because you'll make it a lot easier if you do that. So what we're going to do is we're going to go ahead and just factor out the 3 out of the bottom. So we have x plus 1 times e to the 2x. And then the bottom we have 3 times x plus 1. Okay, and by doing that, see, you're making the function a lot easier. You could even write this is e to the 2x over 3, which could be written as 1/3 e to the 2x like that. Okay, so by doing that, then the derivative is a piece of cake. Okay, can you tell me what the derivative is in your head? Okay, you'd have a 1/3 first of all, and then what's the derivative of e to the 2x? 2 e to the 2x, right? Okay, like that. So then you could multiply the 2 times 1 to get 2/3 e to the 2x. And you could write the answer that way. You could also write it, if you wanted to, as 2 e to the 2x over 3, like that. So what you've done on that is you've simplified that function before you did the derivative. Okay, that'd be the idea. All right, the only thing that you got to do on this, though, is if you look at this function, if you just look at the fact that you have x plus 1, e to the 2x over 3 times x plus 1, just want to point out that what would happen at -1? Function would be undefined. You would actually have an asymptote. You'd have a vertical asymptote there, so the derivative wouldn't exist there. So really that's what you do, is if you can simplify something first, do it. If you jumped into the quotient rule on this, you would eventually get the same answer, but it'd be a lot more work. It'd be very messy. So be on the lookout for that. Does that make sense? Okay, look for stuff. All right, so that was easy. Okay, let's take a look at the next one here. All right, now this one we're going to do f prime of x. What does f double prime of x mean?
You did it twice.
You do it twice. You do like a second derivative. So we're going to do a first derivative and a second derivative. Okay, now this one, what kind of rule would you use on this one? We've only learned 2 today, the product rule and the quotient rule. What does it look like? Product rule, okay, all right, this is not a quotient, okay? So that's the first term, and the second term would go like that. So we're going to need to use a product rule on this when we do this. So the first derivative, and remember the product rule, I'll write it down. You don't need to write it down. I just do first times derivative of second plus second times derivative of first, okay? So I'm going to put in the first is just x the third. Then we're going to multiply by the derivative of e to the 3x plus, and then we do the second, e to the 3x, and then we multiply that by the derivative of the first. Okay, like that. So that's how the product rule gets set up. And then what you want to do is you want to do these 2 derivatives, and then we're going to simplify it, and then we'll do a second derivative. Okay? All right, so what we have is x the third. What is the derivative of e to the 3x? 3 e to the 3x. Everybody got that? You want to do that automatically. That's a rule that you want to learn. So that's x to the third times 3 e to the 3x. Okay, and what's the derivative of x to the third? 3x to the second. Okay, that's your first derivative. It's not simplified. So let's go ahead and simplify this. So if we do this, we would have 3x to the third, e to the 3x. And then over here we'd have 3x to the second, e to the 3x, like that. Now you got a couple of choices that you can make on this one. What we can do here is, it would be okay to write your answer that way. There's nothing wrong with writing your answer that way. So we could like stop there. Is there anything else that you could do with that? You could factor. Okay, yeah, let's go ahead and factor. So it looks like you could take these things out. You could take a 3 out. You could take an e to the 3x out. And then what could you take out for the x's? X squared. Remember, you work with the lowest exponent. That's some algebra background stuff. So we would go 3x squared, e to the 3x, and then have the blank parenthesis like that. Okay? Now if we do this, what we're going to have left is you're going to have an x there, because you got to multiply that by x squared to get the x to the third. What would you have in the second position? A 1. Good. Okay? And again, you got to develop the habit. As much factoring as you're going to do, if you factor something, multiply it out in your head and make sure it's right. Don't mess up on that. Okay? So that would be we're going to call that our first derivative. Again, you can write it in either form. You could write the answer that way, or you could write the answer that way. That's your call. All right? So now when we go to the second derivative, you can do the second derivative. What you can do is you can either work with this form or you can work with this form. It's your call on that. You could either differentiate with this or you could differentiate with that. To me, I think I would probably like doing in the first form a little better, because it's really just a product rule. But when you do this second derivative, what I'm going to do on this is we're going to focus on it this way. We're going to do this derivative, and we're going to do that derivative. Both of those things are product rules. So you could just do each of those things separately if you want to. And that's what I'm going to do. Or you could go down to the bottom, and if you go down the bottom, you could do a product rule there. So I'm going to do it this way. So to begin with, if you just look at this box right here, that's a constant 3, so I'm just going to write the constant down. This is the way I'm going to do this. Then I'm going to apply the product rule in there. So I'm going to take the first, which is x to the third, and I'm going to do the derivative of the second. Okay. Now what I'm going to do on this one is I'm going to do this in my head, which you can do. So what's the derivative of e to the 3x? Okay, 3e to the 3x. Okay, so you can go ahead and do that in your head if you want to. Then you got to go to the second. The second is e to the 3x. And then the derivative of x to the third is what? 3x squared. Okay? Now look at that for a minute. Make sure you follow that, because I'm doing some of that in my head, and you can begin to do that. So what I'm doing is that's a constant. So just write it down. And then in brackets, you got first derivative of second plus second derivative of first. I haven't even changed that yet, right? I got to do that next. Does that look okay? All right. Now let's see. Let's go to the next one. So now I'm going to look at this second piece right here. So I'm looking at kind of this second box. It's slightly different. So when I do this, I'm going to just write the 3 down, and I'm going to have my bracket. So the first is going to be x squared, and then the derivative of e to the 3x is 3e to the 3x. Okay, again, that's first derivative of second. Now I do it backwards. The second is e to the 3x, and then I multiply by the derivative of x squared, so I get 2x like that. Okay, so that's how that goes. That would be one approach to doing the problem. All right, so what I'm going to do now is I'm just going to clean that up a little bit. Does everybody follow what I'm doing there? I'm doing it one step in my head, and you can begin to do that if you want to. So what I'm going to do from here is just kind of multiply stuff out. So this right here, if you do a distributive property on this, I'm just going to choose to multiply this out. I'm going to have 3 times 3, or 9x to the third times e to the 3x. Okay, so I'm doing that. Then I'm going to multiply this out. 3 times 3 again is going to be 9, and that's going to be x squared e to the 3x like that. Okay, that's multiplied out by distributive property. Okay, then I go here, then I'm going to do those. So I've got 3 times 3 is 9. Then I have x to the second e to the 3x, and I go this way, so I've got 3 times 2 is 6. Okay, then I've got just a x and an e to the 3x like that. Now that's just multiplying stuff out. Now what I'm going to choose to do, I could have done this a different way, is see if I have any like terms, and then maybe do some factoring if I can. All right, so if I look at this, here's what I see. These things right here are exactly alike, aren't they? They're exactly alike. X squared e to the 3x, those are like terms, aren't they? So you could put those together. So if you did that, you would have 9x to the third e to the 3x. These go together to make 18. X to the second e to the 3x. And then at the end, you've got a little bit different term. That's a 6 x e to the 3x like that. Okay, yes?
I'm assuming in the first step we multiply 3 times x cubed.
Yep.
Use the power rule, but wouldn't that reduce that x?
Now, see, I've already got the derivative right here. That right there is the derivative. Are you talking about that or the second step?
The second step, because it's 9x cubed. I was wondering was
Now
that.
what I'm doing there is I'm multiplying this right here. 3 times 3 is 9. X to the third comes down, e to the 3x comes down. And then this one right here I'm doing 3 times 3 is 9. And see, all I'm doing is just 3 times 3. I'm doing that times that. So I have a 9x squared e to the 3x. I'm doing distributive property. See, it gets messy. The algebra gets messy in calculus. It's messier than you're used to. And then here I'm just doing this. 3 times 3 is 9, x squared e to the 3x. Here I'm doing 3 times 2 is 6, x e to the 3x. I'm multiplying. You gotta look at that visually the right way when you have a lot of stuff going on. Now what I would do from here is you could actually factor some stuff out of this now. So and you could take the answer. The answer there is okay actually. You could stop there. But I like to get students to factor because it prepares you for what we do later. So if you look at this, the factoring, first of all, what would you use for 9, 18, and 6? A 3. What else would come out? How about the x's? What comes out? The smallest exponent, so x comes out. Okay, and what else? Yeah, e to the 3x comes out. You have an e to the 3x everywhere. So you've got that. So we've got e to the 3x like that. Okay, then we'll draw a bracket and see if we can do this now. Now see, you got to learn to try to do this in your head. So you're doing this like this. You're going to do, what do you multiply 3 by to get 9? By 3, right? What do you multiply x by to get x to the third? X to the second. So that's what goes there. Okay, now go to the second term. 3 times 6 is 18. X times x is x to the second. And you got that, or x. Okay, then the last one, you've got 3 times 2 is 6. And then you've already got the x to the 3x. So that's an answer right there. That would be a factored answer. Is just write that as 3x to the 3x. 3x squared plus 6x plus 2. Okay? And you could try to factor that last thing there. That last thing might factor. Let's try that. I don't know. So if we did, if you look at the 3x squared plus 6x plus 2, let's see if that factors. That might factor. So we'd have like a 3x and an x to get 3x squared. You would have a 2 and a 1. I don't think that quite factors, does it? I thought it might, but it doesn't look like no combination would work. So that looks like that's it. Okay. All right. So that's what it is. Okay. You guys now seeing that 90% of these problems are algebra, right? The 10%, little 10% is the calculus. It's not the calculus that's the hard part for students. It's the algebra. So you're going to get better with that. All right. By the way, there's more than one way I could have done that algebra on that problem. That's just what I chose to do. Okay, let's go to the next page. This last page on here, I want to do one thing here. And just a couple of these table problems. I just like these table problems because they make sure that a student understands how to write out a product or a quotient rule correctly. So if you're doing a problem like this 74 that I took out of the book, well, this is a product rule. Now, the first function is f, and the second function is g. What you're going to do is you're going to use that table format of the function values and derivative to solve this problem. So the first thing I'm going to do is just put this in the product rule. So you just take the first, don't do anything, separate it down. Then you're going to multiply by the derivative of the second. Then you do it backwards. You do the second. And then you multiply that by the derivative of the first, like that. That's your product rule, like that. Okay? Now what you're doing, when you see this bar, x equals 1, what does that mean?
The whole thing?
It just means x is 1, right? It just means that you just plug in x equals 1. So what you really want to do is just write this as f of 1 times g prime of 1 plus g of 1 times f prime of 1. Now, you could have skipped that, step and just went there immediately if you want to. I mean, that's it. Okay? Now what you got to do is just look at the table and look everything up. So f of 1, well, let's see. Here's f of x. There's 1. F of 1 is going to have to be 5. That's what goes there. Okay? G prime of 1, well, here's your row for g prime. There's 1. So the value of the derivative of g is going to be 2, like that. Okay? Now you got g of 1, so you look at the row for g, the column of 1, so that's a 4. And then f prime of x is going to be, you have the f prime row, column like that, so you'd have that. Does everybody see that okay? Just looking up the table. Okay, that's how you're getting the values. So that would be 10 plus 12. So then that would be 22 would be an answer to that problem, then should be what you get. Okay, let's do the next one. Any question on that? Okay, that's just basically a way to kind of check you on the product rule. And the next one, what kind of rule you're going to work with? This is a quotient rule, right? It's a quotient. So this one you're going to go bottom times derivative of top. Like that, just write it like that, and then it's minus the top, which is f of x, times derivative of bottom, and then it's all over the bottom squared like that. So that's how you want to start the problem, and then you're going to evaluate that at x equals 2, and then you'll look this up with you'll look up your chart on that, okay? All right, I'm going to let you guys go ahead and try to finish this one, just give you a minute to sort through that. Really what you're doing is you've got g of 2 times f prime of 2 minus f of 2 times g prime of 2 all over g of 2 squared. Okay, so I'll let you guys see if you can finish that up then. And then we're going to close this off, and then we'll start our next section here. Just get your information from the chart and see if you can fill it in.